We're talking right now about the graphs of sine and cosine, and in the past we've been discussing this whole idea of the unit circle, and now we're going to take information from the unit circle and actually graph a sine curve and a cosine curve for in an xy coordinate plane. I want to at least explain to you what this picture is showing. You should see that this is a unit circle. Every radius moving out there is a distance of 1. And in the middle here, you can see we have this blue 0. That is the radian measure of the angle. And out here is the coordinate that that radian measure is sitting at. And as I move my dot along the curve of the circle, you can see that this number right here is changing, and that is the actual radian measure of the angle. And this coordinate up here is changing as well. My coordinates are in decimal form, so you aren't going to see any square roots or fractions. Everything is going to be in square root form. So if I do estimate the value of pi over 6, the estimated value of pi over 6 is about 0.52. And you can see that that radian measure is 0.52, and this decimal value up here would be the square root of 3 over 2, 1/2, which is pretty close, not too far off. As I continue to move along the circle, you can see that my angle is growing and my coordinates are changing to where I'm now up here at pi over 2, which is about 1.57, and my coordinate is at 0, 1. Also notice that they have carried out, it's kind of like I have unwrapped this curved arc so that it now lies straight along the x-axis. So this is about 1.57 out here, which is the length of the arc in radians. As I move along, you can see that my coordinates are being reflected as changing, my x's are changing to negative. Down here, both my x's and y's are negative in quadrant 3. And then in quadrant 4, my x's are positive, my y's are negative. Okay? Now, let's actually turn on the sine graph. I'm going to click this guy down here, which is going to give me some more information about my radian and degree measure and how those compare, as well as my arc length and what those sine and cosine values are. And I'm going to turn my trace on, which is going to show the graph of the sine curve as we move along the unit circle. What you should remember from the past is that sine on the unit circle is represented by the y value of the coordinate. And so right now you see my y value is 0, and I have a little red dot at 0, 0. And as I move, what's going to happen here is you can see that the height or the y value is 0.42, and you can see this little red dot is at 0.42, and that's why this graph is moving along the way it is. As I move up here to pi over 2, now again, we said earlier pi over 2 is about 1.57, and the y value up here at 1.57 is 1. And you notice that at 1.57, or pi over 2, my vertical height, or my value of the function, is 1. Moving along my circle, now you're going to see that the heights of all of my rectangles as I draw these in, the heights of all of them are getting smaller and smaller and smaller. And that height is being reflected by the curve of my sine graph moving down. So now you can see that I'm at this point, -1, 0. My y value is 0. We've talked before about this angle being pi. So at an x value of pi, my sine value is 0. What's going to happen as we move into quadrant 3? Well, we know in quadrant 3 our sine is a negative value. So you'll see the graph of your sine curve moving into the negatives all the way down to where I'm now down here at 0, -1. My y value, or my sine value, is -1. And you can see down here that at 3 pi over 2, the sine value is -1. All the way until I would continue on back to 2 pi or 0. What you'll notice about the sine curve is I can continue to go around and around and around that circle, and this graph will continue to move up and down and up and down the more and more I move around the circle. This sine curve will never end. But what I've shown you here is one complete cycle of a traveling around that unit circle, and you can see that that one complete cycle occurs in 2 pi units. And so what we call that in trigonometry is the period, which is just one complete cycle. So the period of the sine curve is 2 pi units. It's the distance of one cycle. Well, let's talk now about the cosine curve. Now we know that on the unit circle, the cosine curve is the x, or the cosine ratio is the x value of your coordinate. So notice right here that I have a radian measure of 0, that's going to be my x value, and the x value of my point on the unit circle is 1. So you can see I have a point up here at 0, 1. As I move along the curve, what's happening is that the x value is decreasing because I'm getting closer and closer to the y-axis, to where I'm now up here at pi over 2, right? From here all the way to the top is a distance of pi over 2 radians. My x value is the cosine value, which is 0. So I have a point at pi over 2, 0. As I move this dot along the circle, look and see what is happening to my cosine graph. That should make sense. It's negative, and you can see that as I move along quadrant 2, cosine is negative in quadrant 2, so my graph should all be below the x-axis. Moving down through quadrant 3, he's also negative, but he's getting closer and closer to the x-axis. Because my x value is 0 at 3 pi over 2, I will have a dot at 3 pi over 2, 0. And then finishing out the rest of our unit circle, I now come back to 2 pi, and I'm back up here now to the top at 1. So the cosine curve is similar to the sine curve in the fact that it starts and goes on forever and ever. Again, you will see that the period of cosine is 2 pi also. It's the distance of one complete cycle. And you also notice that cosine starts up at the top, and that it moves down to -1, it comes back to the 0, and then moves back up to 1. So some differences between the sine and cosine graphs. Let's just do this all one more time. I'm moving my circle all around. I've got one complete cycle here of each graph. If you want to think about it in groupings of 4, my cosine curve in the first section starts at the top and moves to the middle, and then it goes down to the bottom of the graph in the second section, and then moves back to the middle in the third, and then back to the top again in the fourth. As opposed to my sine curve, which always starts in the middle and then goes up to the top. Starts in the middle, goes up to the top, and then in the second grouping it comes back down to the middle again. In the third section it goes down to the bottom, and then in the fourth section it goes back to the middle. Again, both of them, your period is 2 pi. That's the distance of one complete cycle. Have a great day. We'll see you tomorrow in class.